This is the CN Seamless Mach 1. This is Josh, this is Gary, I'm Tay, and today we're gonna put it through its paces. You ready?
Let's do it.
Let's go. What are we about to get into, Mr. Cleveland?
We're about to see a very well-built, portable CNC plasma unit or oxy-fuel torch cutting machine.
Now, Josh, what is CN Seamless?
So we're a company out of Raleigh, North Carolina. We actually started when we were in school, we're all NC State engineers. And essentially, we came together to build a portable CNC machine that could let on-site fabricators design and cut and do their full independent process with a single machine that can be mounted pretty much anywhere and cut any 2D profile with either oxy or plasma cutting.
Are you guys excited to see this thing? I assume it's in there.
That's right.
How fast can it go from in there to cutting a part out of this plate?
Give it less than 2 minutes.
In the box to start cutting, right?
To design that might be an extra 60 seconds. Give me 3 minutes.
3 minutes?
3 minutes.
Under 5,
Under
probably
5.
3.
Right on.
Okay.
Let's see how fast we can do it.
Okay.
Okay, I'm gonna start. Are you ready? Now, I will say, there's a Hypertherm 85 over there that is plumbed and ready to go.
Is
Okay.
it turned on?
No.
No, so we do have to turn it on.
And there's no torch or ground lead hooked to
No torture, the ground is hooked to the table. So we're kind of cheating a little bit. Okay, ready? 3, 2, 1, go. Oh, look at that. Ha! Looks like a spaceship. I'm gonna get in your way. Here's what I'll do. I'll clamp the metal down. How's that?
Yeah, we just had a whole big thing about safety.
Well, you know. Josh probably wouldn't even need me to, but I'll do it anyway. Plasma cutter's on. Now, this is a big part of the system, right? This tablet.
Yes, so this is what's gonna actually control the software, the machine. It's all run on this tablet here.
Cool.
So you can see that's it coming out of e-stop.
Oh, and it's already moving around.
It's moving up.
Wow, it's quiet.
I'm gonna lock this plasma torch in here.
So this is just a standard machine torch from
That's right.
Hypertherm, right?
Pretty much any barrel style torch is gonna work.
Can you see this? Do you want to tilt it up?
Right now,
So
we're gonna go-
you've already started the process of designing this part in your included CAD software.
Yes. So we got a 4x4. We're gonna call it an outside shape. We're gonna locate it on the corner.
Nice.
Then we're gonna go to add shape, circle. Would you say that was a 1/2 inch?
1/2 inch circle or holes, yeah.
I'm gonna call it 1/2 inch off the X. Yep, that's the Y. 1/2 inch off the X here.
Okay.
Pattern. I'm gonna call it, what do you say?
3 inch spacing.
3 inch.
And 3 inch. Wow, that's fast.
All right, now we gotta tell the machine where to actually place it down. So I'm gonna clear this stock out.
Okay.
I'm gonna tell the machine the origin that I wanna actually move it.
Got to turn the magnet on. So
Magnet
that's a
goes
magnetic
on.
base like a mag drill.
I'm gonna say I wanna put the corner right there. I'm gonna put the alignment to 2 points. Here, there. Materials, we're cutting with a Hypertherm 85.
85. 3/16.
3/16, so it's gonna go pretty fast. Say,
What do you have on there?
and
45.
I'm gonna click run. To load up the G code, start.
Is it about to actually cut?
I'm gonna plug in the plasma cutter here.
Oh, forgot one. Dude, you're cruising.
All right, so lower it down to the right pierce height.
Do you have to just eyeball that?
It'll usually touch off. I didn't put the
Oh, it
ohmic
will
clip.
touch
I got lazy. So now we're ready to pierce.
Wait, so do you have an ohmic sensor on this?
Yeah.
No
Yeah, you
kidding.
can plug it into here.
Oh, cool.
So-
you just don't have it on right now.
So we're ready to cut right now.
Wait, so that's it? Yeah, that was 2 minutes, 45 seconds. Even
Under
with
3.
the plasma cutter plugged in.
So you pulled it out of the box, designed the part, we're ready to cut in under 3 minutes. That's sick. And that wasn't even that complicated. Granted, simple part, but
Yep.
there's a lot of pre-made geometry in here.
Makes it super easy for any fabricator or welder to pull up a design they want to make the pattern, dimension it, and then get to cutting. So
The amount of people that ask me questions like, should I get into CNC plasma cutting? 9 times out of 10, the barrier is, well, do I have to know CAD? And I'm like, or they ask me to teach them CAD over the phone.
Yep.
And I'm like, I don't work at a community college. You know what I mean?
Right.
Like, that's huge.
Yep.
Yeah, welders don't want to, they don't want to think. They just want to do. You know what I mean?
yep, they want it to be seamless.
Nice.
Hey.
Nice. Can we cut?
Go for it. Click pierce.
Oh, hell yeah. Ready?
Yep. I don't know what I expected.
Yeah, I thought there would be a warm-up. Got it. So that was cool. I mean, it really does not matter where your material is.
Yep, it's a weird thing. It's like it's a unique problem to CNC because most tables know where they are in space.
Right.
This is like one of the only things where you're gonna pick it up and you're gonna tell it where your stock is. And so since you're moving this thing around, you have to do the extra step, of course, of telling it where to actually put the part you're trying to cut, which is great because you can mount the stuff and you can tell it exactly where you want to hole and indicate that, or the part wherever you want to cut out of, take advantage of stock material. But it does mean that, yeah, you have to give this a point of reference out in space.
Well, CNC machines are not smart per se. They don't know what you're doing. Even our table over there, you have to tell it where the stock is.
Yep.
And it operates on a perfect XY, so it's your job to align it with the table. Here, you don't have to align it to anything, and it's like a mag drill where you can actually stick it to the stock itself.
Exactly.
It's not like you have a table that you bring the stock to, you're bringing this to the stock.
Yep.
We don't do a lot of field work, but like if we did, this would be just like on your service truck. You have a Trailblazer, a torch set, and I would put this on a service truck. Like,
Yep.
you got to, especially in like boat repair, architectural repair, structural stuff. I mean, my buddy Jake does almost exclusively large steel erection,
Yep.
beam bolting and fabricating and notching and all that.
Yeah.
I could see this just living on the back of a truck to serve that industry all day long.
Yep. I think we heard one time that there's 2 types of steel erectors, one that admit that they're, having to do a lot of field cutting, and ones that are not telling the truth.
Yeah.
So it's like, a lot of steel erectors will definitely get a good use out of
You
this
can
thing.
prep all you want in your shop, but you're going to be
Something.
cutting stuff in the field. I would love to see you switch over to at least the oxy head, and then we
Right
can
on.
see kind of how that all works.
Yep. So this thing is built to be modular and quickly change to the oxy attachment. So
Super cool.
that's your plasma torch that comes off. This plasma module has a little lock on it, slides out. That's how the machine knows what is plugged in.
Oh, nice.
And then the oxy attachment, which also fits in the case, it's gonna have that same style connector. Slide that in,
Wow.
lock it down. Torch comes over here, tighten down this thumb screw, and then lock it all the way with the cam lock. So now the machine now knows
Are you
it's
for real?
swapped to the oxy attachment, so it's ready to go.
That is so cool. This is brilliant. May I?
Yeah.
So you just loosen this and pull it out?
Yep.
I mean, that's like, is someone are you an IT guy? Like, this feels like a server
Have you
rack.
built computers?
Like a hot
Negative,
swappable
no.
hard drive or something.
Fresh out of college. That's it.
And so all the like gas solenoid switching and everything happens in here?
That's it. It's really only one solenoid valve.
Right here.
It splits off we got a lot of that, sometimes why are there 2 oxygen hoses? There's a preheat oxy and there's a preheat acetylene, and then the oxygen, it's only one inlet oxygen, and so it splits off the cutting jet independently.
Right.
Otherwise, you would be piping, a lot of the machine torches, you have 2 hoses in. We would have to be piping mixed gas all the way through these hoses, which we don't want to do.
Right. It's all handled right here.
So all the mixing happens in the Kawiki torch at the end of the arm, and you basically set your preheat manually, just like a hand torch, so welders, fabricators are used to it.
Yeah.
And then the cutting jet, you just click pierce on the tablet, and it's going to automatically be cutting away.
Is this stainless?
It is stainless,
Yeah. CNC billet machine stainless.
And then potted, that's where
Yep.
the board goes. So, and we built it to be modular, and the arm here is also modular. So essentially the idea is, we've been around for a couple, 2.5 years now, but as we grow this product,
Whoa.
We develop new arms, new attachments. This thing's going to be bevel cutting, MIG welding, laser cutting, maybe water jet. Pretty much anything we can stick on this platform, we want to build an attachment for, so this thing can do just about anything.
Our designer Spike would love to know if you could put a Sharpie in there and draw the Mona Lisa. Yeah.
Well, we can already do that today.
That's cool.
So this is direct from Quickie. You get these tips off the
right.
shelf. They use these on a lot of their track burners.
Right.
And were generous enough to work with us to make sure we have this nice short barrel, fits our whole package, and we have had sincerely awesome feedback from our customers on these tips, these torches. Super easy to work with. So you can get them pretty much any gas supply like Arc 3. You can hit them up and and you can get them from them. So.
Okay, so these are quick disconnects. You pull the module out, plug it in, plumb in your gas, and you're good to cut.
Yep, you can cut that same part again. It's going to cut right over itself. This time you would just be turning on the oxygen and acetylene.
Right.
You let it preheat, and then it's going to pierce and do all the holes just like
Look
normal,
at that.
so.
Yeah. So once you learn one process, you're good for everything.
Exactly.
Well, I mean, the UI here is rad, and it's so important to make this super simple.
Yep.
Because like any CNC equipment that's making its way into an older industry like welding or metalworking, this is going to be the barrier for people. And the
Right.
easier that this is, the more easily adopted it's going to be. This is cool. And you guys designed all this in-house and everything.
That's all us.
Yeah,
Yes,
that's
painstakingly
super cool.
so. It's taken a lot of mostly feedback. So shout out to the customers that give us the good feedback, because we get people asking us for features and updates, and lifetime software updates come when you buy this machine. We don't
Yeah.
charge any software subscription or anything like that. So
That's awesome.
constantly trying to make it better, and the more we hear from people, the better it gets.
I even love that you can just see the machine on screen,
Yeah.
and it's so fast.
So if you go to the place, that's how it's nice to have that like visual indicator of where you actually cutting this part out. So we'll unlock the arms here. So you can
Look
go
at
and,
that.
and make sure that where you're cutting, like you got a 68-inch diameter cutting range, but you
And
get
it
to
is
really see.
It's a direct one-to-one about how this
Exactly.
thing's
No
oriented.
delay.
Yeah, it's on its own like Wi-Fi network.
Yep. So 5-year warranty comes with this as well. So
It's pretty
we
stout.
stand behind it.
Yeah. You want to do some big oxy cutting over there?
Let's get to it.
Let's do it. I have been beaten by an oxyacetylene torch and an I-beam many a time in my life. And we're just going to recreate basically the environment of a heavy, steel erection person, iron worker, whatever those people are called. A welder in the field working with some big metal. So as far as being in the middle of nowhere and using this, you just need 110, which if you're a field welder, you've got a generator anyway, or hell, I bet you could even run this off of a little power bank or something.
You can. It draws less than an amp, so it's like about a third of an amp. So it's like you can run that. I think one of the 500 watt power banks.
I've got a 1,000 watt. Do we try it?
You can try it. It'll
Let's try it.
definitely work.
Well, so here we go. A little 1,000 watt or 600 watt, whatever it is. But you're telling me it'll run happily off of
Oh
this.
yeah, no problem.
Let's go, dude. So for this kind of cut, all right, so cutting the end of an I-beam off, you start right here.
Yep, you could just tell it point to point. You could also design a line in there and then tell it the top 2 flanges. That way it's actually perpendicular.
Right, I got you.
All right,
Does this thing have a specific name?
This is the Mach 1. This is the first product that we're making.
There we go.
Yeah, so
So we're running off of a battery bank. We are clamped. And clamped.
so
That's a good magnet.
you can go ahead and install the oxy
Yeah,
module.
sweet. I mean, for the record, all the training I've gotten on this has been what you guys have seen. So push that in. And then because our Z-axis moves, you don't have to set this at a specific height, right?
That's right.
So
I'd probably set it about there because you want to give yourself enough space to back off,
about
preheat,
middle.
and whatnot.
Is it all the way up Z-wise?
It's all the way up.
Okay,
Yep,
gotcha.
it's homed.
Okay, cool. All right, so these are the Koike quick connects.
Yep.
Nice. So the valves are open.
Yeah.
There we go. Okay.
So we'll come right here and we'll chop that off.
Sick.
And then
Okay.
we'll go to the other side and chop it off.
Should we do some cable management?
Let's do it.
Okay, so we are going to slice well, this part of the I-beam is 3/8. This looks maybe quarter.
Yep.
Slice through 2 of the 3/8. So yeah, talk me through your setup here once again. The first thing you do is connect to the Wi-Fi. Now, Gary, would you say that this is pretty in tune with what you see most people buying this for, this type of industry, this sort of field work?
I've gotten a lot of feedback that it is, and at least in my market, I'm seeing more heavy equipment repair, rock quarry equipment, things of that nature. But I have heard a lot of guys in the steel erection world doing this with it.
So gas is on. You've got the right pressures for your tips, I assume.
Yes.
Cool.
And the machine will actually tell me the right pressure. So if I go to materials,
Okay.
and I tell it I'm cutting steel, I'm cutting 3/8 to 5/8. It's going to say to use a 0. I actually have a double out in here, but it'll work fine. So it says what to set your pressures at. It does all the feed rates and everything based off that.
Cool.
I'll just click confirm on that.
Now, for reference, this knows that you've put the Oxy module on. It
Yes.
shows it, right? A literal picture of it.
Yeah. And the override cutting jet.
Cool.
Yeah. So that you can test your.
That's responsive.
Yeah. So now we'll go to design. And what we were saying is we wanted to actually not even have to measure much. Just say I want to tap the end of my beam here and come in
Call it 6 inches or
Yeah.
so from there.
6 inches. So we'll say, oh, that's point to point. We'll say I want to add a line. We're going to have the start X position be 6. We're going to have the end X position also be 6. And then I'm going to have my end Y position be whatever that is.
I'll get a tape.
Dang. All right. So now we got our line here.
So now we just have to zero it.
So now I have to tell it exactly. I want to cut with my origin at a point. I'm going to set my origin point. It's a little tricky because you got to unlock the arms and move it at once. So basically what I'm going to do here is set my origin point at the corner of the beam.
Okay.
And that's going to tell it, okay, I want my 6 inches, or my 5-inch, rather, my 6-inch line to come in all the way over here.
Yeah,
so I'm
from
gonna say,
that point.
So that's where my line is going to end up being cut. To see how that moves, it's always going to be 5 inches of wherever I decide to set it in here. So I'm going to say set origin point, and then I'm also going to come in. I'm just going to tell it what the alignment is, because you can tell this machine's not lined up perfectly with the flange. So I'm going to say align to 2 points. I'm going to pick 1 point.
So you just let it sit on there.
Yep, because it'll be the same alignment either way as long as it's the same diameter,
Just let it sit over here. Oh, that's slick.
So now you would go back and you could double check and say, okay, my line is supposed to be 5 inches. And we're right about, or we're 6 inches over.
Yep.
That's pretty much.
You're right there.
Yeah, right there.
So you've got your gas on, everything's drawn. Is it gonna cut from bottom to top or top to bottom?
Top to, or bottom to top
Okay.
right now. And what's gonna happen is, when I get to about halfway through, or when I start seeing, I'm actually gonna stand on the other side and see when it starts to pierce the web.
Mm-hmm.
When it starts doing that, I'm actually just gonna slow it down to about 50% or so.
Travel speed.
Yep, and when it gets through the rest of the web, I'm just gonna get it back to 100.
Cool.
So that hopefully we get a nice, maybe like a 1/2 inch or an inch pierce.
Yeah, so
on the inside
with
of
something deep enough to act as a starting point for when we cut the web.
Exactly.
Cool.
So
Well,
now's the hard part of setting the torch. So we'll do that. Essentially, like we said, you got your preheat. We actually are using chemoline right now. So
oh, cool.
we got chemoline and oxygen. So we just light this guy. You want to do it? Or you
Yeah.
want me?
What's the difference between chemoline and acetylene?
Chemoline is, I'm not a gas expert, but chemoline is essentially
Different name.
Different name. It's a.
Do you know the answer?
We should ask the gas guy.
Our
Yes.
three gases?
Yes, a chemoline is a form of alternative fuel, so it's a propane or LP-based fuel, and it has an additive in it to generate more heat, more BTUs during the cutting process. A lot of people use it for heating as well.
Got it. Supercharged propane.
Yes,
Propane
exactly.
plus.
Propane plus.
Exactly.
Hank Hill would be proud.
I'll let you.
Let's cut
go
a
for
beam.
it.
All right.
Initiating propane
So
plus.
just like any other torch,
That's right.
I like it.
all the way on.
I would crack it, because you got to get the. Yeah.
Looking for that.
Try to close this guy a good bit, because you want to get the oxygen to connect with the flame to connect at first.
Oh, there we go.
Give it a little bit more, and then now turn on the oxygen until it'll like the blue cones will
We need
connect.
that neutral flame.
Yeah.
Oh, there it
you go.
goes.
Yeah.
Okay.
Now you can adjust a little bit easier.
I've never used the Kimmeline, so.
I think you're good.
You think so? Okay.
Yeah. So now I'm just lowering it down to the right pierce height.
Yeah.
This is gonna burn through this stuff pretty quick. But,
Yeah, it's pretty hot now.
Go ahead and click pierce. And then I'll stand.
Oh, it's going. It's in. So you've slowed it down manually,
Yep.
and you're through? Nice.
And then you do have to manually shut it off.
That's sick. Okay, so we just melted the crap out of it at the beginning because I let it sit for too long.
And we're still at 99% battery.
Yeah, that's a good point. Yeah, that's impressive.
Cool.
Okay, so moving to the other side, grab a firm, is it a bottom button or top button?
Bottom.
Bottom button. There we go.
Monroe's already sold.
Unwind itself.
We even own the demo unit that stays in Raleigh, but it's came, you know.
Alright.
All right, now I'll be the arm guy. You be the screen guy.
All right. So what we've done is we still have this design in here, where essentially there's that 5-inch line. So basically, what we're gonna be, this is kind of the weird, tricky part about this machine is we have to tell it, I want to cut like so. Last time we selected the bottom corner.
Yeah.
This time, since it's actually gonna be flipped, it's probably gonna start from the top. But essentially, think of if we're selecting that origin in space.
It's this.
So we're selecting that origin, and then we're selecting that top line.
Okay.
So.
Go down on the Z a little bit. You're going off nothing but feel.
So the sound of that is pretty good because it almost sounds like the paper, like when you hit this oxygen jet. It should sound like a piece of paper is ripping.
Oh,
what I've
cool.
heard.
And is that looking like you want it to look?
So you don't want the blue cones to change so much.
The lower cone? So what would you say, a little more oxygen? Or a little less oxygen?
Try a little more to happen.
There you go.
That's pretty good. I think that would be pretty good.
Paper tearing is a great way to describe that sound.
We've heard
I just love that I have an iPad that controls a fire right now.
So you pretty much are good to click start at this point.
So our Z is at just any known.
Yeah, it doesn't know where it is. It's just like
Okay.
calmed out.
See this?
Yep.
Yep, you're hovering. That's good.
Alright, so you can lower it down to a good pierce height.
Which is what generally? Something like there-ish? Okay.
And then you're not going to need much preheat. So I think you can go for it.
You think so? Give it a little more. Did I hit it?
You can always pause to recover, right?
Yeah.
So now what you're going to do is when it gets to the web,
Yep.
you're going to tap that button to about 50%. So like there. And then wait for it to pierce all the way through, and then you can get it back to 100. We're working on a way to tell it when it needs to slow down and speed up. It's just like...
Well, it's like all you need is a button to be like, this is a web. So, and that's dead center, right? So
Yeah.
it just decelerates and then accelerates past it. Much cleaner, man. Wow, it cut pretty deep too. Gave you an inch.
So you don't need max, you know? It's like
No.
you can actually get better cuts with.
Right.
Right.
Look at you. You seen this work before?
No.
Right?
Well, I've seen videos.
Right.
First time.
Okay, so we have cut the upper and lower flange of this I-beam. Now we need to connect the dots. Nice. I'm gonna get a chisel.
Yep. So
All right, so steps to make the third cut.
we're gonna, mag base it here. We're gonna say I want to cut from that point to that point.
Dead simple.
And then that's
yeah, okay, cool.
This is actually thinner, so you're probably good with even less. It's like that amount of chemicals is probably fine.
Good. All right, so we go start. And then Z down.
Yep.
What do you think, Brent? Good height?
Yeah. That looks good.
And so when it's ready to go, we just hit pierce, right?
That's right.
Pierce. Okay, we're good. Cool.
You can probably tap to speed it up a little bit too. Because you can see the flames coming out of the bottom are kind of drooping.
Yeah.
If they're shooting out at like a 30, 45 degree angle, that's how you know you're cooking.
There we go. Oh.
All right, pause.
Oh, pause. Okay, so good example. I outran it. So rewind,
Rewind.
and then
Have it come a little bit further away from the machine. So
what do you
use
mean?
that D-pad.
Oh,
So now it'll pierce on the wrong side.
Oh, and then come in.
Yep.
So then resume.
Yep. I told you wrong.
And then
I told you to
and
speed
then
up too
pierce
fast.
when it's ready.
Yeah.
Go ahead. Come on, baby. I'm still really fast. Oh, we're good though. Watch your ears. I'm not catching it. Yeah! Nice! I mean, that's what you want. It's all coplanar. Good to go.
The only problem I saw is that your hose wasn't underneath the piece when it fell.
Right.
So that's normally the way it
It would
goes.
be a little more exciting if the hose was right underneath the piece.
That's what you're supposed to do. As a first-time user, you get major props. Went well.
Yeah,
Nice
sweet.
work.
Thanks, man. Appreciate it.
Certified CNC expert.
Well, I've got a little CNC background, but you know, I was a college dropout. I'm not an engineer by any means, you know, like only in my interests.
Right on.
What do you say we do a hole pattern in it or something while we're here?
Yeah.
So we're gonna pierce and cut 4 holes.
That was not going quite enough, was it? So it is going a little bit hotter.
So it's like a curl out. Yeah. Cool. It's grooving. There we go.
It's pretty hard to cut.
Oh, it's looking good. Yeah! All right, so we've seen this thing do some pretty crazy stuff. I think we wanted to see it do some like classic CNC plasma stuff. So we're gonna have Spike render a DXF of our logo. We're gonna have Josh supervise to make Spike does it right, make sure Spike does it right. But the cool part is we don't have to tool path it. We just make the DXF and put it in, and it does all that on that side. Quick selfie, Josh. Yeah. That is seriously impressive. I think you've got a winner on your hands, my friend. That's so clean.
Would you say it's CNC?
That's pretty seamless to me. We've put this thing through its paces today. And I am always excited when I see advancement in the CNC world, especially when it's easy to use. I think that's my biggest takeaway from all this is the simplicity of the implementation of something like this, how light it is, how portable it is. You're either going to be thinking with a tape measure and soapstone, or you're going to be thinking with points and buttons. It's
Right.
like the same amount of time, same amount of effort.
So we really love showing niche products that solve problems.
Right.
And this being a portable mag-based unit that is built very robustly, seems to solve a need. The trace functions that it has, and we're really seeing it in a lot of, like I was saying earlier, some heavy equipment repair, the rock quarries, the steel erection world. There's just so many uses for it. We even have guys who don't have the space to dedicate for a full-size plasma table,
Right.
Or even gravitating to this. But
Well, and I can see why. I mean,
Right.
even outside of the industrial use, if you wanted to make art, again, not your primary design function, but you're good. Like you can, there's a super wide range of it. But
So, in making things repeatable in the field, I think is a big thing.
Big
so, like you
time.
were saying earlier, the setup time, tape measure, soapstone in a square. If you're doing one cut, probably makes sense. You're
Sure.
doing you need something repeatable. You're gonna save a lot of time.
ton of time.
Yeah.
Yeah. How long have y'all been in business, and where does this fall? Like current goals, future goals? Like what is it? Where are you? Where are we within all of it?
Yep. So we started back in college actually. NC State University is where we kind of came up with the idea for this in a senior design class. Ended up making some rough prototypes the year after we graduated. Basically, me and my two co-founders, we run the company. It is us. And so all the decisions we made were to try to get our first product out to market that can essentially be used in all these different circumstances, because we come across a lot of customers that just do regular hand cutting and want to be able to have precision capability with that in all sorts of industries. So the idea was to just make a very versatile machine and see who is biting on it, who it really helps. And then as we're meeting with these customers, going and doing demos, we do on-site demos all the time, talk about their needs.
Nice.
We are constantly getting ideas and other areas where they're like, you've already simplified the ability to hand cut. How can we make this thing do welding? How can we make it do bevel cutting? That's kind of been the inspiration for how we've gotten it to do plasma cutting. Even we started with Oxy. The next is going to be MIG welding and bevel cutting.
That's awesome.
The whole idea is, and we have a whole other range of products that people have asked us, can we take a look at this problem, simplify it so my guy can take a product that is electromechanically inclined and take the precision wondering out of their hands. So that's the idea, is just kind of grow the current products, more offerings for that, and then hopefully grow awareness of the business. We're a couple guys in Raleigh, North Carolina, making cool products. We come out to all sorts of different customers and pretty much just try to grow the business and grow the brand.
Well, I think it's really good that you guys you put in enough work on the front end to where the initial product offering is not just a placeholder for what will be, like a lot of tech companies tend to do. They're like, let me just throw something into the world and it's not going to work, but we're just trying to capitalize on something or make money back. This is a very, from my perspective, very finished, polished product that does its job and does it well. And I think that was very good on you guys, because like you said, people like this, and the suggestions they're giving you are not like negative ones. They're like, oh, hey, what about this? Can you do this? And you guys have positioned yourself to be able to take that in and modify or make new products that obviously then you get to sell at ARC3 and show to people all up and down the country. So, I mean, just bravo, man. Good on you. Just some good Appalachian boys.
Right on. Yep.
Connecting some wires together.
Definitely. Likewise. Appreciate you guys giving us the chance to come on here and show you what we can do and use it in your shop. So very much appreciate the opportunity. And so our website is cn-seamless.com. We've been big on social media, so Instagram, Facebook, trying to grow platforms there and just repost what our customers are doing with it today. And then of course you can go to ARC3. So go there and you can schedule demos with them. Chances are that we'll probably be involved in some sense. But yeah, either of the two, that's where you'll see more about us and ARC3. So
their social media is pretty rad. A lot of cool videos, slow-mos, beauty shots. Go get psyched. Go follow them right now. If you're supporting us, support ARC3, support CN Seamless. It takes a village to bring this kind of stuff to you guys. We appreciate you watching. Any last words from you, sir?
Just contact your local ARC3 branch if you got any questions. And this is one of those tools that after you see it work, you'll start to think of more things you can use it on, because it is so new and there's really nothing like it else on the market right now.
These guys are out of the Raleigh area. If you're down that way, seek out ARC3, chase down, I don't know, Josh. I don't know how hard Josh is to find. Go find him, grab him. You're the guy with the robots.
We're easy to find. Yep.
Yeah.
Give us a shout.
Thank y'all for watching. Like and subscribe as always. We appreciate you, and we will see you on the next one. See y'all.
Take care. Thank you.